What is going on, peeps? It is your boy, the Wired Martian. And today I'm going to share with you some of the weird things that I find, some of the weird behaviors that I find in TypeScript. If you're on this video, you probably know what TypeScript is, so it's cool. So I'm just going to walk you through this application that I have here. So this is a simple Express server using TypeScript. I have a root to get. It just returns hello world. And I have a post root, which accepts two numbers. So this requested body has num1 and num2. Okay, it accepts two numbers and it sums those numbers using this function. So I have a class, which is from here. Calc controller, that is a function called calculate sum, takes in two parameters num1 and num2, sums them up and returns the type of number. Okay, and then I have a model called isum. I am from C# background, so yeah, excuse me. So it has num1 and num2, and that's exactly what I used here. So if you try it, 8 and you get 12, which is cool. So let's start with any. Okay, so any is a type, and it's used to cast values whose type you do not know. So like these values might come from like a dynamic content, or from a user, or from a third-party library. So it's great in that sense. You know, you don't have to do so much hustle trying to map out the complexity of an object, or an object that you might not know, on an object that could actually be anything. It could come at different times, having different content, you know. So it's great in that sense. But the problem with any is somehow it changes the whole behavior of TypeScript as a whole, in such a way that the whole of TypeScript has a could be or could not behavior, is or isn't behavior, like Schrodinger's, how do you say it, Schrodinger's cat kind of behavior. It either is or isn't, and it could be both. I don't think it can be, it cannot be both, but it either is or isn't until you look. And that's how any has made TypeScript to behave. So let's look at the first case of this behavior, right? So this root is supposed to return a sum of two numbers. So, which is exactly what it does. 8 and 4 is 8 and 4 is it's 12. Okay, but now let's say we pass a string of num1 and a number type of num2. Okay, now looking at this from here, I am casting whatever this is coming from. I'm casting this, so this would be the same as doing that. Okay, so I am casting this request.body to this interface. Okay, so right off the bat, I'm thinking deep down, I mean, by the looks of it, I'm thinking, cool, since I'm clearly casting this object to this structure or this model, I'm expecting these to be numbers. However, if this is not a number, I'm either expecting an error or I'm expecting it to convert it to a number. You know, that's off the bat, that's what I'm thinking. Okay, so if I am right, that means this shouldn't change. Let's try it. So we hit send and we get 48, and the 48 is no longer a type of number, but all of a sudden it became a string. Okay, so what happened? The obvious answer is this casting doesn't really do what we think it does, and your interface doesn't really convert whatever is being passed to it to conform to the types. that doesn't look like what's going on here. So if we do some poor man's debugging right here, do console.log, and we check out this model, okay, and see what that looks like. So let's do this call again. Okay, so we're seeing now the model still has the properties, but one of them is an integer and the other is a string. So instead of the request.body object being cast into this interface, the interface seems to change its types to accommodate what the object it's being cast to it looks like. So it's sort of like a reverse of what's really going on here. It's almost like casting in TypeScript doesn't convert the object to the types of the structure that you're trying to cast to. However, it tries to conform to the object that you're trying to cast it to, if that makes sense. All right. So that's one weird thing that I found in TypeScript. That's a behavior. That's an any behavior. That's a could be, could not be kind of behavior. Okay, and that opens a lot of things which are not very great. So for an example, if we remove this, right, and if you look at this here, since we have this model, actually I don't like casting stuff this way. It's I find it weird, and as that is also weird. I mean, I do it, but I don't. Yeah, I prefer this. Excuse me. I think it's better. So since this will conform to whatever this is, doesn't that mean this function would also do the same kind of thing? You know, like you have a function that returns a number, but all of a sudden, depending on whatever you pass to it, it can return a number or it can return a string. So it's almost like this return type of this function is not a law, but it's a guide. This is not definite. So this means that in TypeScript, functions can be misused, since this clearly can return a number of 12 and it can return a string of 48 when I clearly specified the type has to be a number, you know. But this function here is not guaranteed. You know, it's just saying, cool, I mean, I can return a number, but if this thing is not a number, then I'll just return whatever it is. Like for me, if it was me, okay, if it was me, I would expect something like this to say, cool, I would expect this function to do something like this. And say if the type of sum is a number, okay, then return the sum, okay. But if it's not a number, then throw not a number returned, okay. So now let's try this, and let's send this, okay, and you get an exception that's saying, okay, cool, you had a function that was supposed to return a number, but it doesn't return a number. Like for me, it makes sense. It would make sense for a function that clearly specified what it wants as a return type to be exactly that thing, and not compromise and say, it could be not, you know, it depends how you want it, you know. If I do something like this and I say const in1 is equal to request dot body dot num1, okay, and I copy this and do that. num2, num2, and then I do that. Oh, actually, it's n1 and n2. Okay. So the reason this is even happening is you have declared two variables, right, coming from the body, num1 and num2, right? As this root exists, okay, if you were writing this, you don't really know if num1 will be a number, okay? You don't know if num2 will be a number. So it would be wise to do something like that, to say, cool, pass it into an integer. Okay, I mean, that would make sense to say, cool, just pass it into an integer. That way you save. But from just a programming language point of view, like, if we always assume that everything that comes from the user, everything that's external from your program, is a type string. Okay, so that means wouldn't it be wise for this function to say, cool, you know, why you passing things, I'm expecting a number and a number, and you're passing things that have a type that is not specified. Please specify the type and then pass it. Don't just pass me whatever it is that you want to pass. Okay? So sort of like it would force you to do something like that, right? I mean, that would be great. So if we do that, we still get a 48. And this is the same thing I was saying here, is these things, they're not changing the value of that to that type. They're not changing the value of that to that type. This property is changing. This property is taking its type from this property, and it ignores this. This is a guide for your development. As I see it, it's a guide for your development. It's saying, I'm expecting a number, but it could not be a number. Well, if it's not a number, then there's nothing I can do about it. That just sounds weird and wrong. Like, it shouldn't be like that. Okay, here's another one before I let this go, right? I've made a couple of changes here. I said, here's a sum, and I'm casting it to a type of any. Okay, and the reason I'm doing that is because on the next line, I want to change it to an object. Okay, and I want to return that object. So let's try that and see if it works. Let's say send, boom. You get a sum, you get an object, machine age 18. Not cool. Like, there's just things that I expect from a language, like off the bat, like just by looking at it. Like, if you're casting something, take the shape of that thing. If you don't take the shape of the thing, it's also weird. So TypeScript is weird, but it could also be misused, and that's on the developer side as well, I feel. Now there's like ways you can avoid this. So for an example, you could write a class instead of an interface, and on the construct of that class, convert each of the properties that are passed into an integer. All right, and before that even calls this function, it will tell you like, hey, you're passing things that cannot be passed into the types that are specified within the parameters of a function. So whatever you're trying to do, before I even do it, it's not going to work, right? It would do that for you. Another thing you can do is tighten up your tsconfig. So, like, always strict true. This one is a pain in the ass. Strict null checks. No implicit any. strict function types, and no implicit this. You could make your application a bit tight, right? It wouldn't really change the behavior, but it would try to force you to writing code which is most likely to compile as the way you look at it. All right. Okay, so awesome.